Hello everyone, we are from Group 3 of Section 4 Physics Class 2025. Today, we're going to present our experiment on kinematics in 2D dimension. Our lecturers are Dr. Muhammad Sufi and Puan Nora Zrin. I am Loa Shirong. My metrical number is AA240200 and here are my group mates.
My name is Daniel Kovjunzer and my metric number is AA240942.
My name is Lin Chuanjie and my matrix number is AA240738.
Good morning to my fellow friends and lecturers. My name is Zeming. Today I am going to talk about demonstration videos.
I am Yong Weng Seong.
Now, let me talk about our objective. For our intention in the experiment, the focus is to investigate the horizontal projectile motion of an object launched with an initial velocity parallel to its horizontal axis. The primary objectives are: number 1, to verify the formula for vertical displacement, which is height equals to 1/2 times gravity acceleration times time to the power of 2. And number 2 is to calculate the final velocity of the projectile and determine its angle relative to the horizontal axis at the moment of impact. Second of all, I'm going to talk about the apparatus that we used. First is a volleyball. It acts as the object in motion, allowing observation, measurement, and understanding of its movement in the air. Number 2 is measuring tape, which is used to measure the height and range of trajectory, which provides spatial data for calculation. Number 3, we use a timer, which is a timing device used to record the duration of light, enabling an accurate calculation of velocity and acceleration. After that, we also need a table with known height, which serves as a platform for allowing the ball to fall from a specific height that doesn't change. We also need a pencil, which is used for creating markings on the floor where the ball lands for a more accurate measurement.
So I'm going to talk about the procedure of the experiment. First, we have to measure the vertical displacement or the height of table using a measuring tape. Next, push the volleyball gently so it rolls off the table and falls to the ground. Step 3. Start the stopwatch as the ball leaves the table and stop the stopwatch until the ball hit the ground. Next, mark the landing point of the ball on the ground with a pencil. Step 5. Measure the horizontal distance r from the point where the ball leaves the table to its landing point using a measuring tape. Next, record the time of flight and the horizontal range. Lastly, repeat the steps by pushing the ball with slightly larger force.
For our data analysis, we can measure the time using the timer and vertical height using the measure tape, and the relationship h equal to 1/2 times g times t power 2 can be verified by comparing the calculated height from the formulas to the measured height from our demonstrations. In our demonstrations, we are using different force level, and the horizontal distance can be measured, and we can observe how increasing the force affect the range of trajectory of the volleyball. Before we calculate the final velocity, we need to find the horizontal velocity and vertical velocity. For the formula of the horizontal velocity, which is Vs equal to range over time, and the vertical velocity, the formula is Vy equal to gravity times time, and the gravity is constant, is 9.81. So lastly, we can calculate the final velocity and its angle. So the formulas of the final velocity is root over vs squared plus vy squared, and the angle for the final velocity is 9 minus 1 Vy over Vs, so that we can know the angle of flight.
The first question is, what is the trajectory shape for the projectile? The trajectory shape of this projectile is parabola, which the characteristic of parabola is the horizontal velocity is remain constant, but the vertical velocity is increased linearly over time. The second question is, what is the horizontal motion for this projectile? The answer is, the horizontal velocity for this projectile does not change. Third question is, explain the vertical motion for this projectile. The vertical velocity starts at 0, increase uniform due to the gravitational acceleration. The fourth question is, explain the time of flight for this projectile. So the answer is, the time of the object spent in the air depends on the height from where the object is dropped. The last question is, explain the independence of the horizontal and vertical motion and the impact velocity. The answer is, when the object hits the ground, it has both horizontal and vertical velocity respectively.
These 3 videos is how we conduct the experiments, so you guys can watch it. Okay. Let's begin now. From the experiments, we know that the horizontal velocity Vx are a bit different, which are 0.298 for first experiment, 0.412 for second experiment, and the last is 0.530. Okay, for vertical velocity Vy, the value are same, is 68.67 for 3 experiment. For next, for the impact velocity V, the velocity are almost same but a bit different, which are 68.67 for first experiment, 68.671 for second experiment, and the last is 68.672 for the third experiment. So for next is about gravitational acceleration, that's mean G. So the G is 9.81 for 3 experiment, and the range is from the first the initial point to the final point are a bit different, which are 0.268 for the first experiment, 0.371 for the second experiment, and the last is 0.477. So the height is same, which are 0.755 for 3 experiment, and the times is also same, which are 0.9 for 3 experiment. So now we're going to talk about conclusion. In this experiment, we gain a lot of knowledge and learn a lot of physical theory, and we learn how we conduct the physical experiment. In conclusion, projectile motion is generated by the independence of horizontal and vertical components and the influence of gravity on the vertical motion. So in this experiment, there are 3 types of physical theory involved. For the first is Newton's law of motion. So Newton's law of motion, there are 2 kinds that involved in this experiment, which are Newton's first law is about inertia, and Newton's second law is about vertical velocity is influenced by the gravity acceleration of 9.81. So for the next is about Galileo's principle of superpositions. So the Galileo states that the horizontal and vertical motion are dependent. And the last, we learn about the energy conservation. The principle of energy conservation states that the energy is neither created nor destroyed, so it may transform from one type to another. Okay, so this is our minute of meetings. The photo are the proof lah. Okay, for the meeting 1, we conducted at block A18 room B303 on December 6, 2024. Okay, for meeting 2, we also conducted at the same place, block A18 room B303 on 20 December 2024. The time is 8 p.m. to 9 p.m. something. And the last meeting we conducted online platform we use Google Meet on January 2, 2025. The time is 7 to 8 p.m.
Here are some of the references that were used in our experiment. Presenting from Group 3, thank you very much.